Hi everyone, welcome to Mathemly. Welcome back to our neural networks series. In the last video, we followed data as it flowed through a network and saw how forward propagation leads to the network's very first prediction, that is its first guess. But now comes the big question. How does the network know whether that guess was right or wrong? That is where the loss function comes in. In this video, we will explore what a loss function is, how it measures error, and why minimizing that error is the ultimate goal of training a neural network. Are you ready? Let's dive in. In the last video, we saw how data travels through the network during forward propagation, where each neuron processes inputs, applies weights and biases, and passes the result forward until the network makes its very first prediction, what we called the first guess. Now that the network has made that guess, the next question is, how do we measure if it is any good? That is exactly where the loss function comes in. It acts as a scoring system that tells the network how far its prediction is from the actual answer. Let's go back to our house price prediction example. Suppose the network predicts $280,000, but the real price is $300,000. The difference between those two numbers is the error, but we need more than just a difference. We need a consistent way to measure how wrong the prediction was. The loss function takes that difference and turns it into a single numerical score called the loss value. If the network predicts accurately, the loss will be small. If it is far off, the loss will be large. So, in simple terms, a small loss equals to a good prediction and a large loss equals to a poor prediction. You can think of it like giving the network a performance score after every guess. This score is what the network uses later during training to learn and make better predictions over time. Now that we know what the loss function does, let's take a closer look at how it actually behaves. The loss function doesn't just measure a single prediction, it looks at how the network performs across all examples in the dataset. In our house price example, imagine the network makes predictions for 10 different houses. Some predictions might be close to the actual prices, others may be far off. The loss function takes all these individual differences and combines them into one overall measure of performance called the average loss. This tells us, on the whole, how well or poorly the network is doing. Here's what that means practically. If most predictions are accurate, the average loss will drop, so the model is improving. If the predictions are still scattered, the loss stays high, so the model needs more adjustment. So instead of just checking one guess at a time, the loss function provides a single, reliable signal that summarizes the network's total error. This is what guides the next phase of training, where the network updates its weights to minimize that loss and make better predictions next time. So there isn't just one universal loss function. The type of problem you're solving determines which one to use. For regression problems, like our ongoing house price example, a common choice is the mean squared error or MSE. It works by taking the difference between the predicted and actual prices, squaring that difference, and then averaging across all the samples. Squaring the difference does two things. One, it makes all errors positive so they don't cancel each other out, and it punishes large mistakes more heavily than small ones, meaning the network learns to pay extra attention to big errors. For example, if the model predicts $280,000 for one house and $290,000 for another, but both should be $300,000, the total loss reflects how far off it was on average. Now, for classification problems like identifying whether an image contains a cat or a dog, we use a different approach called cross-entropy loss. Instead of comparing single numbers, it compares probabilities. If the network predicts 0.9 for cat and 0.1 for dog, but the actual label is dog, the loss will be high because the confidence was in the wrong direction. You don't need to memorize the formulas, just remember this. Every loss function has one job: to give the network feedback on how far its prediction was from the truth, whether it's predicting prices, categories, or anything else. So what happens after we calculate the loss? At this point, the network knows how wrong it was, but knowing the mistake isn't enough. The real goal of training is to reduce that loss over time by adjusting the network's parameters, that are its weights and biases. You can think of the loss value as a kind of performance score or feedback signal. If the loss is high, it means the predictions are far from the truth. If it's low, the network is getting closer to the target. Here is how it works in practice. The network makes a prediction. Let's take the same one. It estimates the house price at $280,000 when the real price is $300,000. It measures that difference as the loss. Then, in the next round, it slightly adjusts its internal parameters to improve the next prediction. Maybe now it predicts $290,000. With each iteration, the network learns from its mistakes, gradually closing the gap between predicted and actual values. This process happens thousands of times during training, each time pushing the network's predictions a little closer to reality. Over time, the loss curve, which starts high, steadily drops as the model improves, just like a student studying and performing better with every test. So, reducing the loss isn't just a side effect, it's the entire purpose of training a neural network. The lower the loss, the smarter and more accurate the model becomes. Here's a real-world example of this concept. Think of a golfer trying to sink a putt. The first shot might roll too far past the hole, the next one might fall short. Each time, the golfer carefully observes how far the ball ended up from the target. That distance is just like the loss in a neural network. The golfer doesn't start over completely each time. Instead, they adjust their aim and strength based on past attempts. With every putt, they get a little closer to the perfect shot. It is not about guessing perfectly on the first try. It is about learning from feedback and improving steadily with practice. That is exactly how a neural network learns. After each prediction, it measures how far it was from the correct answer, the loss, and then uses that information to fine-tune its internal settings, the weights and biases. Each new pass through the data is like the golfer's next swing, slightly better, a bit more accurate, and closer to the goal. Over time, just like the golfer eventually lands the ball right in the hole, the network's predictions start to align closely with reality. It is a process built entirely on feedback, trying, measuring, and improving until the loss becomes as small as possible. To sum up, the loss function is how a neural network measures its mistakes. It compares the prediction to the actual answer and assigns a number to that error. The smaller the loss, the better the prediction. And the goal of training is to minimize that loss as much as possible. In the next video, we will take this a step further and see how the network uses this loss to update its weights through a process called backpropagation. If you found this video helpful, don't forget to like, share and subscribe to Mathemly for more data science tutorials. Comment below with what you would like to learn next. Thank you for watching and see you next time.